Hi, and welcome back to Talking Conservation. Now then, recently we've been talking about lime. We've done a whole series of lime, and in one of them, we spoke about using lime at high level. So today we've got a special guest. We've got Steve Hogarth, who is an SPAB Fellow, and he is a rope access conservator with Highlife Rope Access. Now, he's also a mason, joiner, and lead worker. And I'll tell you what, he does what I'd hate to do because I can't stand heights. I don't know why I ever got into this job because I really can't stand heights. I'm even terrible up a ladder. But anyway, there we go. So Steve is doing the very thing I hate doing. And he's going to talk to us about why it's vital to look up. And we're going to dig into some of the details about high level stuff. So the theme of this particular episode is looking at some of the detailing up high, exposure, access, maintenance, and all those odd bits and pieces that we often forget about, but are vital.
Hello and welcome to Talking Conservation,
the podcast all about conservation of old, traditional and historic buildings and sites.
with me, Rich Aylesbury.
And me, Stephen Boniface.
Cool. So Steve was actually passing down the M5 earlier on, and I sent him a message just randomly, as it was, and says, well, actually, I'm local, so that's why he's here, sat in my office next to me. And I thought, great, we'll collar him and we'll grab him for a podcast, which is why he's here, which is perfect. And we've got a little bit of a précis in terms of a running order of the things we want to grill him on. But hopefully this is all going to be useful to all those people out there as well with regards to understanding some of the key aspects of using certain materials we've spoken about in the last couple of episodes at a higher level. And we're going to start off with talking about drips. Now, this is not to do with whether you've got a leaky tap. This is, of course, about the drip detailing and why that's so important, and often the overlooked genius of historic detailing. So, Steve, talk to us about what we mean by a drip and why it's so important. What does it do?
So drip details are parts of a building that make sure water doesn't end up in and on the building. They're elements that throw water away from the building. So that's things like eaves, overhangs, throatings, string courses. And the idea of them is that any water that touches the building has an opportunity to not be touching the building. So they're places where water's running down and it's going to drip away from the building.
Can I just interject there? You've already used a word that I understand, but a lot like throatings. Sounds to me as if it's something a singer might do. What is a throating?
So throatings, and they're kind of a part of the way lots of drip details work. So it's where you have the underside of a detail scooped out in such a way that water can't track horizontally. It would have to go uphill, so it has to drip off where you have these undercut areas under details.
So what happens then if any of these details are missing? Or, I mean, you just mentioned throatings. I mean, over time, people are going to paint, say, windowsills and things like that, and it might get clogged up, or it might get eroded through weathering or sanding too heavily if it's joinery and what have you. Now, what's the problem with all that?
So the problem is, historic buildings on the whole are really well designed to avoid water being on them. They have lots of details built in to avoid the water being on the surface. So water is the real enemy of buildings. All of the damage processes that we're concerned about generally are water driven. So frost damage, salt damage, damp, mold, everything that we're really concerned about is water driven. And historic builders knew that and wanted to keep the water away from the building. And that's the way that drip details work. So we talk a lot about lime mortar and kind of surface coatings and the way that the building works on the surface and kind of within its fabric. But by the time the water is there, you've already missed an opportunity to get rid of it. So what we want is water to be moving away from the building. So if we look at so obviously in the UK, we live in it's wet, isn't it? So if we look at the oldest buildings we have, the vernacular buildings, which are really really built within the landscape and entirely with the conditions in mind. What we see with things like roundhouses and shielings, they're nearly all roof. Everything is roof. There's very little vertical masonry. And these roofs, especially with thatch, had huge overhangs, 1 or 2 foot overhangs. So water never got near the building. You didn't have to worry about your pointing and your lime washing because it never got wet. And then as we've kind of developed through history, buildings have got taller and we've had to cope with the fact that water is going to end up on vertical surfaces. So if we move forward to kind of medieval buildings, with more grand medieval buildings, churches, cathedrals, manor houses, you start to get really complex detailing designed to send water away. So we get things like string courses, things like overhanging copings, hood mouldings. All of this is designed to throw water away.
But they look decorative. So to the untrained eye, and this is, I think, is really important, which I've only learned in more recent years, is that it's not just decorative. It's made decorative because it had a purpose. Because it had to be there for mechanical reasons of getting the water away. And they thought, well, may as well make it pretty. It wasn't just to sort of
exactly,
make it pretty.
Ancient masons absolutely knew what they were doing, and then also made it decorative. All of especially things like string courses. If you see a tall church tower with multiple string courses, so this is a string course is a protruding course of stone. You'll have multiple courses because there's so much vertical area where water can land. So multiple opportunities to just get it away from the building. It all starts to fall apart with our building design when we get to the Georgian period. Gentlemen started to go to Italy, look around, look at the lovely houses, and then they thought, oh, do you know what? Maybe I'd like a Tuscan villa back on my estate in Clitheroe. And conditions are very different in Tuscany. These buildings just weren't designed in the same way. And so that's when we start to get much more engineering to send water away. That's when we start to get rainwater goods, gutters and downpipes to catch, because we don't have those big overhangs anymore. So we start to get more engineered detailing to catch water and send it away. But if we go back to the drip detailing, so in general, drip detailing, things that are giving water an opportunity to fall elsewhere, the way that's working really is like an umbrella for the building. So where like your lime wash and your lime pointing are kind of your Gore-Tex jacket, they're stopping water from getting right onto the fabric and penetrating into the fabric while also remaining breathable. Drip details act like an umbrella. So they give you physical cover, stopping water from even getting onto the building. So even in windy areas, most of our water comes from above. Rain comes from the sky. The majority of it overall comes straight down. So we've got all of these details designed to keep water away from the vertical surfaces, let it free fall elsewhere away from your building.
I found it really fascinating in the building world, where you go and you look at something which is, whether it's a vertical surface on a building or even on a garden wall, and you notice the drip detailing on it. So in other words, you can often go around a coping stone, even on a garden wall, and you can feel the lip underneath to create that drip, because water will otherwise track underneath it and go horizontally. And actually, you see it on all sorts of surfaces, not just windowsills, but even on various parts of a building where you've ever got anywhere water will land on it. You've got this special, it is a drip detail. I can't think of another way of describing it. Rather than just finishing abruptly and coming in at 90 degrees, you've actually got a sort of gouged out area so that the water can't track horizontally, effectively then wick into a substrate if you're not careful.
Yeah. So going back to what you were saying, Stephen, when we have situations where those drip details are compromised because they're protruding, firstly, and then because these throatings are often very small, they're often not noticed, and like you say, they get filled up very easily. These protruding details get broken off very easily, and then also they're in lots of exposed areas which get kind of rebuild turnover much more often. So things like chimneys and the tops of gables are much more likely to have been refreshed and rebuilt through the building's time. and often effective drip detailing just wasn't thought about when it was when these rebuilds happened. And once we get to the position where these drip details are compromised or are now missing, the building, which was designed to only cope with a certain amount of water because lots of it was meant to fall elsewhere, is now having to deal with it at the face. Lots of buildings are very good at that, but they're much better if they don't have to. Any water you can avoid landing on your building is better than trying to deal with it once it's there.
One of the things I often say when I'm training other surveyors or even speaking to homeowners, and perhaps a good tip for homeowners, is to think about where water is running. What is the water pathway down your building, through your building? So think about, where is it landing? It's landing on the roof. Well, where's it going from there? And where's it meant to be going? Is it going there? Is it being blocked? Is it being stopped? Is it going somewhere else? When it's running down the face of the wall, where is it ending up? Where is it running into? And so I think some of the clues to look for, and some of the things I've found over the years, useful things I've found over the years, is to think about water pathways. And that will often give you a clue as to where you're going to find problems and what you need to deal with. Would you agree?
100%. So one of the absolute best things you can do to understand your building is to get an umbrella and go and stand out in the rain and look at your building and see what's happening, see where the water's falling off, see where it's going. And every time you will see something you hadn't noticed before. The water will do what it's doing. And like you say, the paths that the water's taking, you can see them when it's raining. You'll see exactly what it's doing. You'll notice any issues like drip detailings that aren't functioning properly. So if you've got string courses or windowsills and water's not dripping off the front of those, it's tracking back to the wall. That's a problem that you can then explore further. If you've got gutters that are leaking, that's a problem you can explore further. If you've got a downpipe and no water's coming out of the bottom of it in the rain, again, we can look at what's going on. And it's issues like this where the main source of water is going in the wrong place. These are the issues that are really urgent to fix. When we generally talk about damp in a building and we're looking at kind of low levels of moisture in certain areas, condensation, that kind of thing, those are often kind of slowly progressing. Whereas water ingress, water that is raining and getting into the building, that needs stopping straight away. You need to get straight onto that.
I can tell you a little story about how water gets into a building. Many years ago, and I'm talking about in the 80s, I was involved in property management, and we dealt with a block of flats, an 8-story block of flats. And on the top floor, this occupier, the chap who owned the flat, kept complaining that water kept coming in one of the windows when it rained. And so we went up onto the roof, which was directly above. We tried everything. We repaired the roof. We repaired the parapet. We did everything. And we could not stop this water coming in. And so eventually I took a colleague, and bearing in mind, I said earlier, I can't stand heights. I sent this colleague onto the roof with a hose. There was a tap out there, and I told him to dangle it over where this window was whilst I was inside. And all of a sudden, whilst he was dangling this hose, this water suddenly came in through the window. So I shouted, "Stop, stop, that's it, that's it." And we looked. And what it was, okay, this was a modern building, it's not a historic building, but what it was a slight split in the mastic seal between the window frame and the brickwork. And that slight split that you wouldn't have noticed if you hadn't have done that test with the hose, we wouldn't have even seen it. But because we saw where it was coming in, I was able to look out, saw this split. We remasticed the window. He never had a problem again. And I think that demonstrated to me, and this was 40 years ago, demonstrated to me how easy water finds a route into a building. even the slightest root the water will find a way in. Is that what you found over the years as well?
Absolutely. What you're describing, your story is a weekly occurrence for me. It's always the way. Flowing water, flowing rainwater, any small gap, it'll just pour through. It wants to get in, and it will do its best.
From a homeowner's point of view, I mean, you've already said about going around in the rain and looking, but some of the things we've just been talking about, you wouldn't necessarily see straight away. So what do you think are the best methods of a homeowner protecting their building from this water ingress?
So really understanding what's going on is always going to be your starting position. So if you have water ingress, if you have damp anywhere in your house, really the first thing you should do is look up. The greatest source of water is always going to be from the sky. So look for the obvious places that are likely to be an issue. So that's always going to be your rainwater goods. So your gutters, your downpipes. Always check those really carefully. If at all possible, look at them in the rain. Or, like you say, with a good hose, you can often get to a house's gutter. If we've had a heat wave, and you're trying to figure out what's going on with your house then. But yeah, anywhere else, really looking around for the obvious issues, obvious holes. Look for the points where water's likely to get in. Anywhere flat that water won't want to fall off, and then any what we would call sky-facing joints. So if you've got any joints in your masonry or other materials which face the sky, water is going to want to pour into those. So you want to check that those are well sealed up. So any coping stones, anything like that.
And I also find the junctions between materials, particularly different materials. So in the case I just cited, it was a metal framed window against brickwork. So where there's different materials, you get different rates of expansion and movement. So you're more likely to get cracking and tearing of seals or anything that's stopping a gap. So look at those junctions as well, I'd have thought.
Absolutely.
As well.
Yeah, and things like where lead meets masonry, or if you can get up there, things like where your chimney flaunching meets your chimney pot. Like, yeah, exactly as you say, any difference in material, you're going to get differential movement, and those are really likely areas to open up.
Just moving on a bit then, when you've got that sort of detailing, it would be really nice to sort of help homeowners in terms of choice of material to use to repair certain things. If you've got an area where you've got an open joint, and whether you shroud it or cover it with maybe cement, dare I say it, because it's more hard wearing, or whether it's a lead coating, how do you pick the right material, I suppose, depending on what it's got to do? And when can you do it DIY, and when do you need to call in a pro? I mean, it's a very open-ended question, I appreciate, but is there any kind of tips or ideas you can help us with to sort of get a better understanding of what's best in what situation?
Yeah, so really, in terms of, so if we're talking about masonry drip details, what you really want to look at is the water loading. So how much water that detail has to deal with. So on something like a string course, which is low down the building, there's a lot of other material around it. It doesn't protrude that much. It's only trying to deal with what's landing on the vertical face. In those areas, it's likely that just the pointing mortar you're using for the surrounding masonry is going to be competent for that amount of water. Small string courses, that kind of thing. If we're talking about real sky-facing joints, so things where it's kind of a small roof, essentially, things like coping stones, then it starts to get a bit more complicated, and you're going to need something more durable to deal with the greater water load. And detailing coping stones is always a nightmare. Detailing sky-facing joints is always a nightmare. You would try and detail them out. So if there's logical ways that you can cover those or shroud those in simple but effective ways. So depending on your details, sometimes areas of lead work can be introduced to cover those details, which will shed the water. But otherwise, you would probably want to be looking at a more durable lime mortar, you're essentially going to be looking at adding some level of hydraulicity so that it copes with just the sheer load of water.
Brings us on quite nicely in terms of the next bit of what we're going to talk about is about talking about those mortars in exposed areas. And we did in the previous episode about chimneys and high exposed areas in terms of the different options available to you. And whilst you'd not necessarily always, but you would steer towards an air lime generally because of its performance with regard to vapor permeability and capillarity and all those other things. Actually, of course, you need a different set of criteria when you're looking at shedding water, aren't you?
Yeah.
Or not letting water penetrate quite so much. The common exposure areas that we know have got sort of chimney stacks and pointing to those chimney stacks. You've got the copings that you just mentioned, you've got the verge tiles, those open sky what's it called?
Sky-facing joints.
Sky-facing joints,
Yeah.
I'll try to remember that. Parapets. In your experience then, talk us through some of the decisions about the different mortar mixes, lime mortar mixes, where you would use, whether it's an NHL product or a pozzolan mix or otherwise, the thought process you go through when you're looking at and evaluating those areas.
Yeah, so I guess when we talk about exposed areas, I think it's really important that there's a kind of hard line to differentiate between something that is normal vertical masonry but very exposed. So something like a chimney stack or an exposed gable in an exposed area, things like church towers. So a kind of something that's essentially a normal vertical wall but that's high up. And I'd like to differentiate that between details which form a weather shedding detail. So something which is essentially a small roof. So something like a coping or a chimney flaunching or a sky-facing joint at the top of a parapet.
Designs
like
to have water physically
so something
go on
that water is going to land directly onto, and it's going to have a high load of water from above.
Gotcha.
The next thing that's important to consider is how that area of the building is able to work as a whole. So if we have a large mass of masonry, that part of the building will be better at dealing with a high water load because it's able to absorb and buffer the water so that small areas don't end up as saturated. So as it receives water, if you've got a large area of masonry, it's able to spread that out quickly so that the areas don't end up with these concentrated, saturated areas where you get real issues with things like frost damage.
So shedding isn't always a good idea then in that case. Is that what you mean?
Sorry. So if we're talking about vertical masonry,
If
we're talking about vertical masonry, the mass behind it is a relevant thing to consider. Now that all comes to a head where we have things like chimney stacks, where there's very thin masonry. Often chimney stacks will be brick chimney stacks are often just one brick thick, and they just don't have the capacity to buffer much moisture. And so in those cases where it's vertical and exposed and there's not much mass of masonry to buffer the moisture, then we need to ask the masonry to shed water. And it's in those cases where we'll start to look in a vertical wall at something much more hydraulic. Again, it's going to be a very difficult decision and it's going to be specific to each building, but it's there where you'd start to look at pozzolanic mixes, hybrid mixes and NHLs. Where you have a mortar that wants to shed water, it's easy to think, oh, this is exposed, so I need something harder, I need something less porous. But your margin of safety is on both sides of you. So if your mortar is too hard, then your margin of safety in terms of preserving the fabric, in terms of it being able to dry effectively, starts to be lost. And equally, if your mortar is too soft on the other side of this margin, then it's going to be vulnerable to damage. It's going to be vulnerable to excessive wetting. And so it's really a question of balancing. Kind of if we talk in very, very general terms, most of the time, in terms of what I do at work, most of the time on vertical surfaces, we're not going to be going above something like an NHL 3.5. And even then, we're much more likely to be using a hybrid mix, so a combination of an NHL with quicklime to soften it up.
Before we leave the subject of vertical surfaces,
Yeah.
I just want to differentiate. I mean, I'm over here in the east of the country, you're in the west of the country, and you're from Wales, aren't you? So, your weathering is going to be significantly different to what we experience over here. But of
Absolutely.
course, there will be, and we're not just talking about high level areas, because there will be some buildings that will be sea facing. And that will be a different type of exposure. Not only will it be wet, but it'll be salt laden
Yeah.
wet
Yeah.
as well. So, can you just talk us through some of the decisions that might be appropriate when we're dealing with those more specific coastal areas, maybe on the west side of the country or even on the east coast where we're facing the North Sea, which is one of the roughest seas in the world, so I'm told. So what should we be thinking about in those situations with salt added to the mix as well?
Yeah. So these very exposed areas do get very tricky. What I would tend to look at first is exactly what kind of complete system we have in place. Lots of traditional buildings in coastal areas have kind of a whole system approach to protecting the building from these very aggressive wind and rain. They're more likely to be lime washed or hulled or rendered, maybe just on the exposed gable, or they're more likely to have detailing like hung slates or hung tiles, again, often just on the most exposed gable. If I was having issues with an area like that, I'd try to figure out if that was missing from the building I was working on, and if it would be appropriate, considering the building and the buildings around it, to reinstate something like that. If we can add proper extra protection rather than just relying on the pointing, which is a very minimal measure to deal with water, then that's really worth considering. Just in general, the kinds of mortars we'd be using in coastal areas, for example, you're going to have to look at the substrate and consider your priorities with that building. If we have lots of water and salt attacking a wall, something like an air lime, something very soft, will do a better job of protecting the rest of the masonry. It will draw that out. It will act sacrificially more effectively than something like an NHL. So there's always going to be a compromise in terms of how accessible the area is, how often you can refresh the finishes, the pointing, things like that.
So there's an element of this surface being perhaps sacrificial, and therefore the homeowner that's facing this might not have a once and for all fix. It might be that whatever they do is going to have to, it's just an ongoing maintenance thing. And sadly, with some buildings, unless you do that, they're going to suffer. And therefore, some homeowners have just got to accept that their building is a high maintenance building in that regard. Would that be a fair approach to some of those buildings, maybe?
I would say that everything you do to any building is an ongoing maintenance thing. There are no, oh, I fixed it, that's done now. Everything you ever do, you're going to have to come back and maintain.
It's still a matter of when.
It's just a matter of when, yeah. And yeah, if your building is suffering particularly aggressive attacks from the weather, it's going to need a bit of support. It's going to need more help to deal with that.
But crucially, correct me from wrong from what you're saying though, is don't accept the fact it's going to require additional maintenance, not choose a material that's going to reduce that maintenance burden. Is that where we're coming from?
Yeah. So there are definitely compromises to be made. There are materials that will require potentially slightly less maintenance, but won't deal with the entire system quite as well. You really have to deal with these things on a case by case basis, and building and the owner and the significance of the fabric all need to be taken into account. There is no compromise that will work for every situation.
Before we move on to the high exposed areas, which I know you keep wanting to get back to, and I keep stopping you and talking about the vertical surfaces, but I just want to touch upon something that's been quite controversial recently, and that is the coating of walls with lime wash or a shelter coat. Now, over the years, over here in the east where we've got timber frame buildings, I've done it quite often with timber frames where we coat the whole thing, frame and panels, etc., with lime wash. But of course, it's hit the news headlines with the church that's had the tower whitewashed. I personally have no problem with that, because I think we need to protect these buildings. And the reality is a lot of these buildings have had these surfaces removed in the past by perhaps in the Victorian era and what have you. And so we've got used to seeing these buildings stripped, but they were never intended to be. Is that a view you share, or do you have a different view on this?
I suspect I share your view. So lots of buildings were built and designed and maintained with particular systems in mind. You can't expect them to work if you've taken some of that system away or you've not maintained that system. I wouldn't send you out in a rainstorm without a jacket because you're not designed for that. Equally, if your jacket got torn and ripped and was letting water in, I wouldn't send you out in that. I'd repair your jacket or give you a new one if necessary. So my general approach with all buildings is that in terms of respecting the fabric, we should do as little as possible and as much as necessary. And sometimes what's necessary is an entire coat of Limewash. Sometimes what's necessary is an entire coat of Harl. Sometimes that is the minimum bar to get this building functioning. To me, when I look at it that way, I mean, you can't, how do you argue with that? If that's the minimum that's necessary, what are you going to do? Just let it stay wet.
So that's vertical surfaces, which I think we've definitely done to death now, and we've done a bit on previous episodes on that as well. Let's now talk about the more shedding. Is that right? The shedding type materials and those sort of things, which again require a different mix still, I assume. Dare I say it, more towards the much harder, denser, cementitious type sort of things.
Yeah.
Is that right?
Yeah. So some details are purely water shedding, and anything you put up there, you're trying to form part of a small roof. So something like the top of a parapet, the exposed joints kind of in the top of that have to shed water as if they were a slate. So there we're going to have to find a compromise where the mortar is able to perform and deal with that amount of water loading. And so often we'll be looking at much harder binders. So we'll be looking at things like NHLs, things like greater proportions of more aggressive pozzolans, as well as things like natural cements, Roman cements, that kind of thing. And again, it's going to be a compromise. Stone doesn't want to have very hard mortar in between it. Again, we're going to go as hard as necessary, but as soft as we can get away with. And sometimes, in some situations, if we've got a say a well-detailed parapet on a church in West Essex, it's not going to have to deal with much. And the limestone of the parapet is going to do well to buffer the moisture. You know, it's not going to ask that much of the mortar. And so there we might get away with something like an NHL 2 or a gauged NHL 3.5 mix, a small amount of pozzolan. That might be fine. Whereas if we were on a church in Dartmoor with a badly detailed Victorian parapet, granite wall, well, there it needs to interact with that system and that level of water loading. And there we might be looking at something more like, I think this is a really good application for something like Prompt. So the natural cements, the Roman cements, which don't cure as hard as Portland cement and maintain a greater degree of vapor permeability than Portland cement, but still have really excellent weather shedding properties. We can also temper some of the negative effects of the binder with the aggregate that we use. So just in terms of compressive strength, if we use soft, porous and crushable aggregates, things like stone chip, stone dust, particularly limestone aggregates, we can temper the negative effects of those very, very hard, very impervious binders. This is also going to make them more reversible. If you're trying to chip something out, you know, in future, and it's got hard nuggets of quartz and granite in there, you're going to have a hard time getting out and replacing it. Whereas if you've got a mortar with nice, soft, oolitic limestone chips or chalk chips that make up the aggregate, removing that in
That
future,
becomes
making
a
it more
fracture line when
reversible.
you actually come to chip it away almost.
Yeah.
Isn't it? You chip away the. Okay, that makes sense. I never really thought about that. If you got it wrong, it's reversible. That's the
Yes,
difference. Which is,
And there's-
which is something we never really consider. I must.
Oh,
I've never really
absolutely.
considered it,
Yeah. So there's a lot of factors that you can play around with a mortar to try and get some of the characteristics that you want, but maybe temper some of the characteristics that you don't. I'd happily get very nerdy about all of those and how we can do that. But I think that's a podcast in itself.
After a few whiskies.
Yeah.
Well, I don't know about you guys, but I think I am mortared out for the time being. We've done a lot of episodes on this, and for those listeners, they've got a whole bunch of different information on all things to do with mortars. We've got some really useful. I've learned some really useful stuff on. I'd never really considered the different types of mortar when you've got a vertical, a sky open joint. What's it bloody called again?
Sky facing.
Sky facing joint. There we go. I will get it eventually. The sky facing joint and then a vertical surface. And thinking, for me, I was thinking it's a chimney. You use the same mortar on both the ridge tiles and also there. But that's really, really useful. But I reckon we should draw stumps there on all things mortars, because there's some other things that I'd like to speak to Steve about. So thank you very much for tuning in on this episode. Tune back in for the next one, because we're going to chat to Steve a bit further on his work in rope access and whether or not he's scared of heights.
You've been listening to Talking Conservation,
The podcast all about conservation of old, traditional and historic buildings and sites.
with me, Stephen Boniface.
And me, Rich Aylesbury.